In this video, I'm going to be going over a difficult AP Physics 2 magnetism problem, which is focused on magnetic force applied with motion. Moving on. So this question says a particle of charge E and mass m moves with speed v perpendicular to a magnetic field B directed into the page. The path of the particle is a circle of radius r as shown above. So we have this diagram here. And we have these x's, which essentially mean they're pointing into the screen. They're pointing into the screen. So we can use the right-hand rule to solve this problem. So essentially, the right-hand rule says that we can use our pointer finger to show where the velocity is going, our middle finger to show where the magnetic field B is going, and then our thumb is then going where the force is going. So we already know B is going into the screen, so we can point it that way. And then common misconception here, a difficult part of this problem is knowing where the velocity and the force is. So we have to decide if it's going either counterclockwise or clockwise. So originally when I was solving this problem, I was thinking they don't really tell us where the velocity is going. But we can use our intuition and kind of think, well, let's say the velocity is going counterclockwise, so it's going kind of around the circle this way. The force would then be going into the center of the circle, which makes sense because then it's bringing the electron, this electron here, down. But let's say we were going the other way. We're going this way. Then the force is directed outwards. The force is directed outwards when this particle is going this way. So let's say the particle is going that way. The particle would instead want to curve that way, forming a different circle than the one we have. The circle we have right now is going like that. So that's why that wouldn't work. So that means the direction of the motion has to be counterclockwise. Basically, we know we could use the right-hand rule here because it's a positive charge that's equal to the charge of an electron, but it's positive. If it was just an electron, then we would have to use the left-hand rule, and the direction would actually be clockwise. So part B says, what is an equation relating B, E, M, V, and R? So we can pull out our equation sheet. We can see that we have a formula. The acceleration, the centripetal acceleration, is equal to the velocity squared divided by the radius. We also have an equation in magnetism that says the force of B is equal to Q times V times B of sine theta. Basically, if we multiply mass by for this centripetal acceleration equation, we get the force centripetal is equal to V squared divided by R times mass. Because this is a circle, and it's going around this way, the force centripetal is actually going to be equal to the force magnetic, since both are essentially, the magnetic force is essentially causing the centripetal force. So we can set these equations equal to each other, and we get V squared divided by R over times M is equal to Q times V times B sine theta. So we kind of get a question here, what is sine theta? Or what is theta in general? We have this thing here that says the speed v is perpendicular to a uniform magnetic field. So this angle here is the angle between the speed and the magnetic field. And because it's perpendicular, that means it's 90 degrees. Sine of 90 degrees is equal to 1. So essentially we can just cross this out because it's 1, and it'll just QVB times 1 is still equal to QVB. So we can simplify this equation. We divide both sides by v, and we will get v divided by R times M is equal to QB. And then let's solve for R, because the next part of this problem, it'll make the next step easier. So we can solve for R. We'll divide V and M both from the left side of the equation. We get 1 over R equals QB divided by V times M. Since the reciprocal of R, we can just flip the numerator and the denominator, and we will get R is equal to V times M divided by q times b. So let's remember this for the next step of the problem. Let's just write it down. R is equal to V times M divided by Q over B. So this next step says what is the period of the revolution. So we're trying to find capital T, which is the variable for the period of the revolution of the particle. So I kind of immediately think, what is the velocity of the particle, the average velocity if a particle completes one circle? So essentially, the distance, velocity is just distance divided by time. So we could just do, we know the circumference of a circle, which would be the distance of this whole circle, is just equal to 2 pi r. So we can get V average is equal to 2 pi r divided by velocity is distance divided by time. So the period of one complete circle, the period to do this whole complete circle, would just be equal to this variable t. So we can then solve for t. We can get t on its own side. So we can go t times v is equal to 2 pi r. We can then divide v from both sides, and we get t is equal to 2 pi r divided by v. We can see that we actually have r that we solved for from the previous slide. We can then substitute this for the r variable here. So here we will get 2 t equals 2 times pi times our substitution, v times m divided by q times b all over v. So this is essentially equal to this top part times 1 over v. So this basically what will happen here is v and v will both cancel out, and we will get the equation t is equal to 2 pi m divided by qb. And that is our answer. Thank you for watching.